Okay, so we've got one more term we're going to talk about with vectors here, and this is the projection of V onto W. And we're going to give a formula here of how to find it, but let me explain what that means. So let's say we have two vectors, V and W. Then the projection of V onto W, think about it like the shadow of V onto W. So if if the sun was up here and it was casting a shadow down onto W, we'd get this vector here. And that blue vector that I drew, that's the projection of V onto W. So here's how we find it. We're going to multiply a number times W. We're going to scale W. So the number that we find first is V dotted with W over the length of W squared. So we're going to do it here. So V dotted with W is 3 times 1 plus -2 times -1. So that's 3 plus 2, so that's 5. And the length of W here, the square root of 1 squared plus -1 squared, so that'll be the square root of 2. So the length of W squared will just be 2. So we're going to multiply the projection of V onto W here is going to be 5 over 2 times W. So 5 over 2 times I minus J. So that'll be 5 halves I minus 5 halves J. Now, this next statement says, then decompose V into two vectors, V1 and V2, where V1 is parallel to W and V2 is orthogonal to W. Now how you do this is your V1 is just going to be the projection of V onto W. So we found that. So our V1 here is 5 halves I minus 5 halves J. And your V2 is going to be equal to V minus V1. So V2 here, you take our V, 3I minus 2J, and subtract 5 halves I minus 5 halves J. So this would be 3I minus 2J minus 5 halves I plus 5 halves J. So we're going to take 3 minus 5 halves, which is 1/2. So we'll have 1/2 I, and then we have -2 plus 5 halves. So that's 1/2 as well, so plus 1/2 J. So that's our V2. So there's our two vectors where V1 is parallel to W and V2 is orthogonal.